Okay, hello and welcome to my YouTube channel. This is Ramani Online Mathematics. If you know you have not subscribed, please subscribe and share. Now we are looking at a graph of constant velocity. Okay. Now, when it comes to the velocity, we have the graphs of velocity. We have two graphs or two types. We have one displacement time graph. Then we have velocity time graph. Okay, so these are the two main kind we are going to look at. So for the displacement time graph, always the horizontal line, which is the x-axis, is where the time is, and the vertical line is where the displacement is. Okay, so these are the graph there. Now if the object is starting from the initial point, then we start from, here it be the 0. So this is what we are going to have. Is that okay? So this is what we are going to have. Now if you look at this one very well, this becomes the object, this becomes the velocity, because displacement with time will still give you the velocity, well, regardless, right? But here will be in terms of t comma s, that's time with what? Displacement. Now looking at this one, normally this u here becomes the gradient, okay? Because if I do this, so if I do this, you know that from here to here is our time, right? From displacement, sorry, because that's the distance there. So here will be s and this will be t. So it means that my u, which is the velocity, will be s over t, and that is true. That's the definition for the velocity, which is displacement over what? Time. Okay, so the results of displacement time graph will give you what? Velocity, and that gives you a gradient. The gradient of this is that. Now let's also look at where we are starting from the initial point. So from the initial point, the same thing here. Here is the velocity, and here will be what? Time. So here, what it means here is that this place will be vt, which will give you the acceleration, right? So velocity time graphs ends with what? Acceleration. So in this place will be what? V, and here will be t. So for gradient is changing velocity. That will be, in fact, it's supposed to be, here will be u. So it's supposed to be the initial, which is v minus u over what? T. But the reason why even this place is supposed to be the initial minus the final, but you realize that the initial is 0, so even s minus 0 is still be 0. That's why I've written s over t. So here to v minus u over t can still be written as v over t. The reason being that the u is starting from the initial point, so that will be 0. So this is what we get. You can also have one that is traveling not from the initial point, but from any point. So we can have something like this. Let me do it here for you to see. Straight away, it will be traveling from the top here like that. So here becomes our acceleration in terms of st. So here the initial point is not 0, and the final will not also be what? 0. So you should take note of that. Now, the area under this triangle you see here, whether we get a trapezium or a triangle, whatever you get, is the total distance covered by the object. So you should take note. So anytime they ask you to find the total distance covered by the object, you just find the area under the shape that you had, or the figure. So if the figure is triangle, you find the area from, you use the formula to find the area of a triangle to find it. Whatever you get becomes your total distance or the displacement. So we are going to look at an example of this. Now let's look at first example. A train starts from rest from station P and accelerates uniformly for 2 minutes, reaching a speed of 60 kilometers per hour. It maintains this speed for 10 minutes and then retards uniformly for 3 minutes to come to rest at station Q. Find the distance PQ in kilometers. B. The average speed of the train. C. The acceleration in meters per second squared. So first, this one, somebody might decide not to use a diagram to do it. I have no problem with that. If you can do it without a diagram, that is nice. Okay. But here, the diagram will aid you to solve it very easy. So let's see this. Let me show you how you can draw the diagram. The train starts from rest. So let's have our diagram here. So this and that, right? So I said that the train starts from rest. So from rest means you are going to start it from here. Is that okay? So due to space factor, let me do it this way. What is this? So we said the train starts from rest. Station P. So this is station what? P. And accelerate uniformly for 2 minutes. Okay. Reaching a speed of 60 kilometers per hour. So this, since we have 60 kilometers per hour, we are talking about velocity time graph. So the speed will be what? 60 kilometers per hour. Okay. So let me write it as 60. And he used what? 2 minutes to do that. 2 minutes to do this. Okay. So he used 2 minutes to do that. So 2 minutes. But because we are dealing with kilometers per hour, where is it? Kilometers per hour here. Change the 2 minutes to what? Hours. That will be 2 over 60. If you are changing 2 minutes to hours, you divide it by what? 60. That will give you 1 over what? 30. So this place will be 1 over 30. That is in hours. Now let's move on. And it maintains this speed for 10 minutes. So when it gets to this particular point, it maintains the speed. So as it is maintaining the speed, it doesn't go like this again. This is the maximum speed that it got to. So when it got to this point, you decide to move like that. It cannot go again. Once you proceed to the top, it means that you are increasing the speed from 60 kilometers to, let's say, 65 or something like that. So this will go out horizontally so that it will match with this 60 kilometers. It does that for how many minutes? He said that 10 minutes, right? For 10 minutes. Now remember that already here was 2 minutes. So when it comes here, it becomes for 12. So from here to this place, so you don't write 10 here, but rather 12, because from here to this place will be 12, because from here to here is 2 plus 10, that will be 12. So you divide 12 by 60. So 12 by what? 60. That will be 1 over 5, right? 1 over 5. So here will be 1 over 5. Then the last one, and then retards uniformly for 3 minutes. I told you that retardation doesn't mean that the car is moving opposite direction, but rather slowing down. So the car started slowing down. So like this, it slows down like this, okay, for 3 minutes. So you are going to add 3 to already 12 minutes, which will give you 15. So you have something like 15 divided by what? 60, which will give you what? I think 4, right? So 1 over 4. So here will be 1 over 4. Let me write it like this. Okay, so this is what we have. This is the nice diagram that we are going to use. Okay, good. So all this one, this is in what? Time in seconds. Sorry, in hours. So I've converted everything to hours. Now the first question is the distance PQ in kilometers. So we start with P to end at where? Q. First, I have told you that the distance means the area under the diagram there. So if you look at this diagram is a trapezium. And formula for finding a trapezium is, so first I want the distance of what? PQ. Distance of PQ will be equal to how multiplied by from here to here, right? The distance there. So from this place to this place is what? 10 minutes. So 10 minutes in hours will be 10 over what? 60. Plus from here to this place, if you remember the formula for the trapezium, here to that and here to that will be, that was 15. So that will be 15 over 60 times the height. The height is 60. So we have 60 here. Is that okay? Very good. So the distance PQ will be equal to, so if you do everything, you get 12.5 kilometers. So that's the distance, what? PQ. Now let's move to the B, the average speed of the train. So B, average speed of the train will be the total distance covered by the train. And the total distance covered by the train is this. Is that okay? You know, the question says you should work in kilometers. That's why the answer is in kilometers. The total distance covered is the 12.5 kilometers. Okay, so 12.5 over the total time covered. The total time covered is 1 over what? 4. So that will give you 50 kilometers per hour. I hope you understand this one. The total distance is, the total time is from here to this place. That's 1 over 4. And then total distance is the area under this curve. And that is, under this trapezium. And this is what we have here. So that over this, that gives 50 kilometers per hour. Then the last one, the average speed of the acceleration in meters per second squared. Now look, where is the acceleration? The acceleration is here. So you are only going to consider this small triangle here, okay? You know that I said that the acceleration is the gradient, and the gradient will be change in what? The y-axis. That's the change in the displacement, the velocity here. So change in velocity will be v minus u over the time taken, okay? So in this case, our velocity here, is 60, right? Minus initial velocity will be 0. So there's no need to bring it. Over the time here, what is the time here? That's 1 hour 30. 1 over 30, sorry. If you cannot see, this 1 over 30. But before I will proceed, we want the thing in terms of meters per second square. So I will change this 60 kilometers per hour to meters per second. Okay, and this 1 over 30 to what? Also seconds. So look, here will be A equals 60. That will be 60 times 1000, all divided by 3600. And all this is divided by 1 over 30 times 3600. So that's the conversion. 60 kilometers per hour. Remember, that 60 is kilometers per hour. So if you are changing to seconds, 60 times 1000, because every 1 kilometer will give you 1000 meters. So 60 times 1000, and every 1 hour give you 3600, right? So here too is in hours, so just multiply here by 3600. The reason I'm dividing the whole of this one by 3600 is that it's 60 kilometers per hour. So the per is the 3600 hours over 1 over 30. There's 1 over 30 here. It's also in hours, so I'm changing it to seconds, so it will be times 3600. So this is what we have. So our final answer to this is A will be equals to, let me use calculator now, this one there, 0.14 meters per second squared. So this becomes the final answer to that particular question. Is that okay? So that will be 0.14 meter per second squared. So the units are very important if you are changing them. Very good. Let's move to the next example. Okay, now let's look at the second question. Now, please, because of the space, that's why I cleaned this side and I written the questions here. So I'm starting from here. The popular Accra Tema Railway service operates on daily basis. Okay, on a particular day, the train starts from station M and accelerates uniformly to a speed of 20 meters per second. It maintains this speed and then retards uniformly until it comes to rest at N. The distance between the stations is 2 kilometers. 2 kilometers, okay, and the total time taken is 2 minutes. If the retardation is twice the acceleration in magnitude, so take note, retardation is twice the acceleration in magnitude, find by way of velocity time graph. Okay, so we are going to do that. So let's first get our velocity time graph. We what the velocity here will be what time. This one is in terms of meters per second. This is in seconds. Okay, so now we were told that the car starts from station M. So from station M, on a particular day, the train starts from station M and accelerates uniformly to a speed of 20 meters per second. So 20 meters, okay, per second. It maintains this speed and then retards. So it's maintained this speed. So let's maintain that speed here. And after maintaining the speed, it then retards. So you say that it's maintained this speed and retard uniformly until it comes to rest. Okay, but let's indicate the time. Here will be time. Here too will be another time. So these are the diagram. Until it comes to rest at N. So here will be what? M. Here will be what? N. So now this is what we are going to have. Was time given? No. But the total distance covered was what? 2 kilometers. That's the area under this curve. Everything is 2 kilometers. Take note. And the total time taken is what? 2 minutes. So if I make here T1, T2, T3, that means from T1 to T3 is what? 20 minutes. But in seconds, that would be what? 120 seconds. You should take note of that. But you see, the T3 will be the same as the 2 minutes because it's from here to this place. Okay. Now, if that is the case, okay, so now that we have this, we know that T1 plus T2 plus T3 is equal to 120 seconds because it was given to us as what? 2 minutes, the total time. But we are saying that T3 is the same as that 120 seconds. Where somebody may say it doesn't make sense because T1 plus T2 plus T3 is 120 seconds, and you are saying only T3 is 120 seconds. It makes sense. If you looked at the first question that I saw, you realize that the first question that I saw, it was T1. If here is 10, and the train just travel from here to here to let's say 20 seconds, then from here to here it will become what, 30 seconds. From here to here, from the beginning to this will become 30, but only here to here is what, 10 seconds. So what you are trying to say is that if you add this one plus this, it should give us the 120 seconds, but from here up to this place is 120 seconds. So you should understand that one. You can decide to represent that one alone by T, no problem with that. Now also remember that the total distance covered was 2 kilometers, and we said that the total distance covered is the area under this particular object here. Is that okay? The total distance was for 2 kilometers. So if you change 2 kilometers to meters, that will be 2,000 meters. Is that okay? So that will be 2,000 is equals to half multiplied by, from this place to this place, we are using the trapezium rule. That is T2 plus from here to here is T3 by 3. T3 is 120 multiplied by the height, which is 20 seconds. If I multiply this one by this, I'll get 400. 400 divided by 20 will give you 200. Here, this time this will be 4,000. 4,000 divided by 20 will be 200, which will give you T2 plus 120. So meaning that our T2 will be equals to, let's see, if I bring this one here, it level it was 80, so 80, remember, in seconds. Is that okay? So now the question said the time for which the train is traveling at constant speed, so that is from here to here is the constant speed, the time there is what, 80 seconds. Is that okay? Now the next one is that the acceleration, remember the acceleration, we only consider only this place. Or is that okay? Only this place. So our acceleration will be 20 over T1. I hope you know that. 20, or from here to here is 20. That's the distance or the velocity over the change in what time here. That's T1. Let me make some clarification here, because so people may be confused about this one. Let me represent the total time from this place to be T. Okay, let me make here T, so that T will be equals 120 seconds. So that we don't know T3, because let's take the T3 to be only this place, the time covered for only this place, but the T here should be there from the beginning to the end, so that people don't become confused. Now, because of time, the space, I'll clean this side. So I hope you understand this particular area. So let's see something here. What will be your deceleration? You know, we said that if you want deceleration here, remember we said that acceleration, the deceleration is the twice of what, acceleration. So it means that deceleration, I can write this as 2a, which is equals to 20 over T3. Is that okay? Already I've said and I've explained this, that T1 plus T2 plus T3 equals to 120, right? And I'm saying that we should let T should be the total time, which is what, 120 seconds. So that the T3 will only represent this one. If not, people will be confused. So you should let T to represent the total time there. Now, so in this case, I can decide to make T3 the subject here, and here I make T1 the subject here. So if I make T1 the subject here, I'll get T1 to be equal to 20 over A. Then T3 will be 20 over 2A, that will be 10 over what, A. But if I do the substitution here, I know that my T1 is now 20 over A. My T2 is 80 seconds. That's what we worked for. 80 seconds. My T3 is for 10 over A equals 120. So in this case, we have to work for what? A. Is that okay? So you can pause the video and work for the A. So now if you work for the A, let's bring this 80 here so that we have, know that the denominators are the same, so I can add this one to get 30 over A equals, you subtract 80 from 120, we get 40, right? So it means that our A will be 30 over 40. So A will be equal to 3 over 4 meters per second square. So that becomes our what? Acceleration. So you should take note of that. You can let it represent the total distance. Thank you very much for watching.